All right, so now when you look at this problem here, you'll notice, hopefully, that that product is not expected. The expected product would result from this mechanism. So the carbon uses the pi electrons to form a bond to the hydrogen. The electrons in the hydrogen-bromine sigma bond end up as a lone pair on the bromine. And it's this carbon here that's going to use the pi electrons to form a bond to the bromine, because in doing that, what you will get is a more stable carbocation. That carbocation has more hyperconjugation, more hypercon. And then the Br minus will use a lone pair of electrons to form a bond to that carbon, and you'll form that product. So this is the expected product. This product over here, though, is unexpected, but it does come from a carbocation. So all you do is you just mentally erase the bromine and put a plus charge where the bromine is bonded. So there's the plus charge, and there's the methyl group. Now, this is a carbocation rearrangement. We did some examples of these in class. It is not a hydride shift, because a hydride shift doesn't change the carbon skeleton. It just moves a hydride from one carbon to another. This one here, the carbon skeleton has changed. In fact, I now have a larger ring. This ring here is 6 carbons, and this ring is only 5 carbons. So what has to happen is that you have to do an alkyl shift. The only things that can shift are carbons that are adjacent to the carbocation. So this carbon can shift, or that carbon could shift. This thing is symmetrical, though, so it doesn't matter which one shifts. So what you do is you circle the shifting group and have the arrow going straight to the positive charge. What that will do is that is breaking that bond and forming a new bond, because it is an alkyl shift. There are a couple of different ways that you can draw this to try to help you keep track of things. What I like to do is I like to draw the atoms in as close a proximity to their original arrangement as possible. So I'm missing this bond, but I am forming a new bond. The plus charge is now on this carbon, because over in the original molecule, it's that carbon that is losing electrons. This drawing looks kind of crappy, so I'll do the bottom one. If I do the bottom one, I form my new ring. So this ring is now 6 carbons and the carbocation is on a carbon next to a carbon with a methyl group, just like the carbocation is on a carbon next to a carbon with the methyl group. And then the Br minus forms a bond to the carbocation as normal. The reason that this happens, both of these carbocations, this one and this one, they have the same amount of hyperconjugation. The reason that this carbocation forms is because there is less angle strain.